Hey everyone, welcome back. If you have ever tried running someone else's code and thought, why doesn't this work on my machine? Then you are going to love Docker. In this video, I'm going to explain exactly what Docker is, why developers use it, and how it helps solve one of the most frustrating problems in software development. We'll go through a real scenario that every dev can relate to, and by the end, you'll have a crystal clear mental picture of what Docker actually does behind the scenes. Let's say you are working on a Java backend app. You've got it running perfectly on your laptop. It connects to a database, talks to a front end, everything's smooth. Now you hand that project off to a teammate or try to deploy it to a server, and suddenly things break. Maybe the Java version is different. Maybe the operating system behaves differently. Or maybe some dependency just isn't installed on the new machine. You spend hours debugging something that worked fine before, and that's the problem. These "it works on my machine" problems have haunted developers forever. Docker solves that cleanly and completely. Docker solves this by giving you a container, basically a lightweight, portable box that includes everything your app needs to run. Think of it like shipping your code with its own mini computer. Inside the container, you define the exact versions of Java, libraries, system tools, even the base operating system. You build the container once and it runs the same everywhere, on your machine, on your teammate's laptop, on a production server, or even on a cloud platform. It doesn't matter what's installed on the host. Docker brings its own setup. That's why developers love it. It removes the "works on my machine" excuse. Here's how it looks in practice. You write a file called a Docker file. In that file, you describe everything your app needs, like start with this version of Linux, install Java, copy over my app code, and run the app. Then Docker reads that file and builds an image, kind of like a snapshot of your app with its full environment baked in. When you run that image, Docker creates a container, an isolated environment where your app lives. It runs just like it would on your own laptop, but it's separate from the host system. So you could be on a Mac and still run a Linux-based container, or spin up 5 different apps, each in their own container with no conflict. Let's go back to that Java backend example. Now imagine your app also needs Redis for caching and PostgreSQL for the database. With Docker, you can run all three, your app, Redis, and Postgres, each in its own container. They talk to each other like they are running on the same machine, but they are completely isolated. You can even use something called Docker Compose to define how all these containers work together, so you can bring up your entire environment with a single command. That's powerful. It means every developer on your team runs the same stack, and your test and production environments match your local setup exactly. Docker makes development, testing, and deployment more consistent and predictable. Instead of configuring every server manually, you just ship your Docker image. Instead of writing long setup guides for teammates, you hand them a Docker Compose file. And because containers are so lightweight, you can run lots of them on a single machine, which is perfect for microservices, CI pipelines, or modern cloud apps. It's fast, clean, and removes a ton of guesswork from your workflow. So to wrap it up, Docker is a tool that lets you package your app with everything it needs into a container. It solves the problem of inconsistent environments. It makes your apps portable, and it gives you the power to build, test, and deploy with confidence, no matter where your code is running. If you are just starting out, it may seem abstract, but once you try running your app in a container and see it just work, it clicks. Alright, this is the quick overview of Docker.